Right. Hello. Good morning. So I worked on. Let's see. How should we do this? Let's flip it around. Can do this, and then there we go. So I made some changes to the documentation because I'm getting some feedback that. Well, I'm reflecting and getting feedback that like Bonsify should really be about the patterns, right? And that's also why you are attracted to certain like solutions. It's because like the resulting code kind of speaks to you. Sometimes there are like certain abstractions or primitives that kind of helps convey that result, that makes it appealing. But at the end of the day, it's the resulting code. It's not the actual like how should I put it? Like the primitives. And I think like the thing I tried to convey in the beginning here is like we kind of lost that the language can actually be a very good like primitive and abstraction in and of itself. Like we don't need to add to it. We can just use it as is. And for state management, like state management should really only be about solving what's technically difficult to do. In just the language, and that is reactivity. You need some primitive that makes your state observable, and then you need to make your components observers. That's it. Like that's something that has to be technically solved, because that's very difficult. Well, it's not like super difficult, but you would kind of have to implement a reactivity system every time you're going to build an app, which you don't want to do. So Bonsify is really about these patterns, and the new documentation actually reflects that. So what I'm trying as like a tag, or what's it called, like a description now, is like Bonsify patterns for well-structured, artfully maintained components and state management. And that like well-structured and artfully just points to the bonsai trees. Like it's just fun, whatever. Building an application, and I'm just gonna kind of read quickly through things, and then we'll adjust it because I want to kind of listen to how it actually sounds. So building an application is about wielding UI complexity and state complexity. React is a master at managing UI complexity, but comes short as state complexity increases. Like all state management libraries says this. Like React is great, but at a certain point it handles state quite badly. Because it was never really designed to be a state management tool. It was designed to be a UI tool, UI composition. So Bonsify is a set of patterns that helps you manage state complexity. Oh, yeah. It helps you manage component and state management complexity. It does this by grounding you in a core constructor pattern you can apply to both components and state management. Yeah, I think that's enough. Managing complex state management requires you to choose a reactive primitive that components can observe. Bonsify provides its own reactive primitive, but you can choose observable from MobX, signal from preact signals, or whatever other reactive primitive you have experience with. To get going quickly, npm install Bonsify automatic observation. Blah, blah, blah. Complex state management, let's see, requires complex state management is proven to be I want to kind of emphasize that reactivity is kind of the mechanism. Complex state management is proven again and again to I emphasize everything. I don't know. It's my personality, I think. Complex state management is proven. Is proven to be solved better by using reactive primitives. Complex state management is proven to be solved better. To be best solved. Yeah, to be best solved by using reactive primitives. To start using the Bonsify patterns for state management, you need, sorry, like the text is all, let's just drag it over here. Let's see. Complex state management is proven to be the best, to be best solved by using reactive primitives. To start using the Bonsify patterns for state management, you need to choose a reactive primitive for state. To start using the Bonsify patterns for state management, you need to choose a reactive primitive that components can observe. Bonsify provides its own reactive primitive, but you can choose observable for blah, blah, blah. It's almost like I don't even want to using reactive from Bonsify. Okay. Read about constructor patterns. Start with the constructor pattern. Okay, cool. So start learning. Go to patterns. Yeah, whatever. Oh yeah, of course. Now, yeah, this is kind of weird the way this works. You kind of have to click. So I have to click it here. Yeah, and then boop, and then yeah. Whatever. So pattern constructor. The constructor pattern is focused on writing code for components and state management by following the same principle. This principle is exposing first what the implementation is and then how the implementation works. It is important to highlight that implementing new concepts often requires several iterations on what it is and how it does it, where you should not feel constrained by a pattern. But when you're happy with your implementation, this pattern will help the next developer better understand what you implemented. So for a component, it's the component function we know with its name and dependencies, but we think about the stuff before the return statement as the constructor and what we return as a public interface. And then the functions we have after that return statement are methods. And we do exactly the same for state management. It looks exactly like a component, but it uses like a reactive primitive for state, and it returns a public interface, which is just an object. And then we still have the same methods. This pattern is very useful as complexity increases. Think about everything before the return as the constructor of a class and everything after as the methods of a class. But unlike a class, there is no special keywords or this reference. You just point directly to any dependencies, variables, or functions you want to use. So the only thing that changed here now is that I'm being more consistent about using like the props. It looks more like a component now, right? I even have uppercase on the first character, and this is an already known pattern where I remember back in the day with classes, very, very often libraries would expose that you didn't have to use the new keyword. You could just call the class and it would do the new thing under the hood. You would even have like this check if the new keyword was actually used when calling the function. It was very interesting. So I think that just better separates like what is actual like state management entities, just like what are component entities, and what are just plain functions, right? And then it still looks like props. And yeah, so it's basically looks very, very similar. And that helps, right? So it doesn't matter if you're reading component code or you're reading state management code, it looks it's structured the same way. Oh my God. So okay, I have to click this one first, and then it's kind of annoying how this works. Oh, can I actually, oh, look at this. Oh yeah, whatever. So, and then the next pattern is state tree. Like state trees are a pattern. Like you can choose exactly how you want to build up your state management. Like you can have many different like functions creating state management, and you can expose it in any way you want. Like it doesn't matter. But state tree is this idea of just building up this tree of state management, where you have like different properties represents different namespaces in that tree and so on. So building a state tree allows your components to consume all the state of your application from a root object. The mental model of a single state tree is the exact same model as your components. This creates less friction moving between the two concepts, and with the constructor pattern, the code will also look very similar. Building up a state tree is about composition, just like components. So I have a counter here, and then I have my state, and yeah. If you like squint, you could imagine this being JSX, right? And then passing parent state. When nesting objects, it can be useful to pass the parent state. As this is a circular dependency, you will need to use a getter. So here we have a doubler that's using the counter. And then when we create the counter, we use a getter for the doubler, and then we return it from the constant created after it. This is just how you have to deal with. Like if you use the class, you could, in the constructor, you could pass the this reference, but there is no reference to this object yet. The reference is here. So you wouldn't be able to add it. And also like we can't do, like you could argue that we did get doubler and then you would do doubler counter here. That would be nice, right? But the problem is you would create a new doubler every time you get the doubler. So that kind of sucks. But I've been reflecting on this. It would be nice to have some way of dealing with that. But yeah, whatever. This is how you do it. And then when you build a state tree, you also need to be able to dispose of state. So you might initialize state that creates a side effect that needs to be disposed when you later remove the state. So if we have a counter and that counter sets up an interval, you need to be able to dispose of it. So here we have the actual state with not a counter, create counter, remove counter. And when we create the counter, we create, oh, this should be create counter. This should be counter. Yeah. So we create a counter, and then when we remove the counter, we dispose of it if it exists, and then set it to undefined. So yeah, like unlike components, which has like use effect and subscriptions, in state management, you can just dispose of the objects whenever you want. It's a simpler mental model, especially for creation and disposal. Like subscriptions is like the entity lives on, right? After you've unsubscribed to it. But here you control its existence. let's see if I click here first and then there. And then we have protected state. And the point is, like, you can choose any of these patterns. Like, you can choose all of them. You can just choose one of them. You can just read them to get inspired. It doesn't matter. Like, I think there's a lot of value in just explaining the patterns. And also as a team, like, they can read through these patterns. They can choose to adopt some of them. Maybe they want to adjust some of them. And then you could even like fork the repo and make that their own. Like, this is how we write components and state management in this app kind of thing. Yeah. Depending on what reactive primitive you're using, it can be useful to protect state changes. So like MobX, for example, inherently protects state changes because you have to make all public actions, like public methods, into actions. But that has its own overhead of like asynchronous functions and so on. But yeah, so it depends. But you can also use a pattern for it. So protecting state changes prevents components from manipulating state in unpredictable ways and rather force them to use the functions exposed from the public interface. So in our counter, we just have internal state, and then we return the public interface where you can only read the count, and then you have this increase that actually changes the count. So this is like the simplest version of protecting state. Now the count cannot be changed from components. This pattern is especially useful with data to ensure that all data changes has a related server mutation. So here we have a post where we get the post data and persistence, and we just return a getter for any like read-only value we want to expose, and then change title. And inside change title, we just update the title in this example, and then we point to persistence and we update with the new title. So there's no way you can say like post.title equals something. That's an actual runtime error. Yeah, and this just shows how we create the post array. I'm a little bit dizzy today. I'm doing a test. I was in such a bad mood this weekend. So I was like, but why? Like the days were actually really nice. We had like a great weekend, but I felt pissed off all the time. It's very annoying. And then I was reflecting, okay, I did drink a bit more wine this weekend. And I didn't feel hungover or anything like, and it's not that much wine, but it affects your sleep, right? So I was thinking about, oh, by the way, I forgot I need to put myself a little bit like this. I often lean out of the screen. Anyways, so I was sitting in the evening yesterday. Okay, how do I best approach this to get some hard data? Do I don't drink wine and then see how I feel today? Or do I double down on the wine and then collect another data point? So I did the latter. And even though I feel great today, now I kind of feel a tiny bit hungover. So maybe like if you just drink a little bit of wine, you don't feel hungover, but you get in a shitty mood because you just sleep badly. But if you, yeah, I want to check my sleep pattern. Anyways, but if you drink too much, or not too much, but you drink more, you'll get into like a deeper sleep, but you get a hangover the day after. No matter, the conclusion is like, just don't drink wine. Wait, where were we? Pattern protected. Let's look at the next pattern. So this is the component state contract pattern, and this is about how you expose state to your components. So with state management solutions, you often consume root state through a context provider and use selectors to narrow down to the specific state you want to consume. Problems arises if you use TypeScript and your state is at some level dynamic. A value can be there or it might not be there. For example, a component might want access to a user, but the user might be null. If the user is passed as a prop, it is guaranteed it will be there. But if it is consumed by a selector hook, TypeScript will tell you that user could be null. Like just unless you throw an error, right? Consuming that user, which is just as bad. That is why you should not consume state globally, like pointing directly outside of components to some global state object, or using a context provider. Like you provide a root state object through a context and then you like use state, use app state or whatever. Because then it doesn't know, like the type of the thing you're consuming might have a user or not, right? But what you should do is pass it down as a prop. So you pass state down at the root, and as your components narrows down on specific state, also pass the related narrow state down as a prop. So props passing is kind of the thing we're trying to prevent, having like an external state store. But what we have to remember is that we don't have to, like when we say props passing or when we do props passing in the world of React, we do a lot of props. We never pass like an object, right? Because an object can't be safely reconciled because that object will likely change its reference all the time, even though the properties within the object might not change, right? Because you don't know what properties you actually consume from that object inside the nested component. But when you have reactive state, that's actually a good thing. You should pass these like branches of your state down to components, because the components will only reconcile by the state they actually access anyways. So you don't pass that much props. You'll pass like, instead of passing like 4 props, you pass 1 prop where all the other props are within, kind of. And that makes sure that, for example, with the user here, you would have app, and then app would maybe be responsible for the session. And then when you have a user, you're going to pass down a branch of your state that actually has a user guaranteed. So then whatever consumes that state further down in the tree will always have a user. But that can be problematic if you have like multiple levels of your state tree, because what if one component, and this is also why we move it externally, like you have one component that might need, well, even access to the user, right? So you might have like 3 levels nested. You have some state related to a specific feature, for example. And then you have a component that only receives that branch of your state tree. But then that feature just needs the name of the user, right? So what do? Well, you could now like go and refactor all your components like you typically do in React to adjust props passing, so that you actually pass the root branch down to, or the branch that has the authenticated user down to that component, and then it like dives into the specific feature as well. Or maybe you just pass the user next to that specific state branch. But anyways, that's a hassle, right? So what you do is, if a component has been passed a nested state as a prop, it is useful for that component to still be able to access parent state. This can be solved when you construct your state interface. So here we have the counter again, and here it receives the root state. So we have a reactive counter, but we just attach the root there. And this doesn't matter for your state management, right? Because in terms of your state management, it doesn't care about this root. But when you consume that counter, and you want to go back up to the root, you can just say here counter.count, but you can also say counter.root.isAwesome. So you can travel back up the tree in your components, and that's so much simpler, right, than having to refactor. So you can always safely pass branches of any part of your state tree down to nested components, because the components can always like traverse back up just using that branch reference, which is really, really nice. 4, 5, let's see. And then we have the explicit states. Explicit states unions algebraic data types or finite state machines. The concepts are very similar. The idea is that you define state that is in one of either explicit states. So instead of writing this kind of type where you can always sign in, always sign out, you might have a user, you might not have a user, you might be authenticating, you might not be authenticating. Like it's all kind of a mess. You describe more correctly the specific states a session can be in and what behavior is available in each state. So when you're authenticated, you do have a user and you're able to sign out. If you're unauthenticated, you have the possibility to sign in, but you don't have a user. And then session authenticating, you can sign in or sign out. So you're basically like protecting flows this way. So this has several benefits. The explicit states is a string that describes the actual state. So that's nice, right? So you can actually see what are the exact states we can be in. Unlike the one at the top here, it's not like, can you have a user and be authenticating, right? It makes sense that you don't have a user and you're authenticating, but what if you're not authenticating? And if you don't have a user and you're not authenticating, it means you're unauthenticated. But what if you have a user and you're authenticating? What's that state? But that state doesn't exist here, right? So we're very explicit about what states you can be in. With TypeScript, you can narrow down what values are available in each state, and you can exhaust what states are available. It's super nice to consume explicit states in components. You can guarantee that certain behaviors is only run in certain states. Normally, a finite state machine is implemented with a dispatcher type of concept. That means you can ask it to do anything at any point in time, but its internal implementation guards the execution by checking the current state. The bad side to this is that you will never know from a consumption perspective what functionality belongs to what state. So by simply using a pattern, we can resolve this. We have a counter, and that counter can be in an idle or a counting state. And regardless of what state it's in, it always has a count, right? That's not tied to any specific state. So we start out by being idle. So we just return the idle state with the possibility to start counting. And when we call, and only when you're in idle, you can actually start counting, right? Because in a component, you have to actually check if counter state current equals idle, then you have access to start. And then we start, and immediately it changes into counting. So now you can't start it again, right? And in this counting state, it sets up an interval, and it changes the count. And then it returns the state with the stop function, which clears that interval and moves it back into idle. So I've never seen, like I tried many times finding ways to express this, especially taking into account not having to like declaratively describe what functions are available in each state, and then the consumer, or like what state changes are valid, and then kind of react to that to do certain things. This is so much more at least how I think about things. It's like you are idle and then you call a specific function related to that idle state that moves you into a new state. And then you have a function that moves you out of that state. That's how you do your transitions. It's based on what functions are available in each state, which is awesome. And you might think like, why not just have start and stop at the root of the counter, right? But the point is like you can do mistakes. You can call start twice, you can call stop twice. Like you don't control how the consumer calls these functions, and that's the important thing, is to control when these functions are executed. And like we don't do this in programming at all. Like if you create a class, you just shove the methods in there, right? Even though those methods aren't valid in certain states, you just assume that the user will just call it once, right? Because that's makes sense, right? But programmatically, they can call that method 100 times and can create havoc in your state management if that's what you're expressing. So having explicit states and putting functionality with each state, it's excellent. It's like, it's really how we should do programming by default. But it's more of a hassle, right? We're so lazy. Programmers are so lazy, me included. So let's see what we have here. Oh, data fetching. So this one's interesting. Data is also state. The difference between data and regular state is that we need to asynchronously fetch the initial state. Making changes to that state needs to be synced with the server, often referred to as server mutations. There are primarily 3 different strategies to manage this. Local mutations. This is what I've always subscribed to. Fetch data once and apply local mutations to the data, where server mutations is a background process. So here we have some data, and we just make that data reactive, and then we go and fetch the to-dos and shove them in there. In this type of data handling, you can just toggle the completed state of any to-do, push new to-dos onto the existing data array, etc. So we have our state with the data, and we return the to-dos and the ability to add a to-do. And when we add a to-do, we just push it to the array, and then we send it to the server. 99.9999999% of the time, that just works, right? And the user has an insanely snappy experience. Like when we talk about latency, there is like a gradual improved latency. So like, I don't know the exact milliseconds, but let's say from 75 milliseconds and above, there's like there's a gradual improvement of latency when you get towards 75 milliseconds, right? Of UI responsiveness. But if you're able to have it down to like 10 milliseconds, that's like 10 times a better experience. Like it's an ocean between plus 75 milliseconds, or is it 100 milliseconds, plus 100 milliseconds, and less than 100 milliseconds. So like 200 milliseconds isn't like 2 times worse. Or how should I put it? Yeah, you know what I mean. So doing this allows for an amazing user experience. And this is how I always built the applications I've been building. It's doing this because it just creates an amazing experience. It feels native. Hi, Damien. Yeah, so like, I think that having the specific functions available in the specific states is like that was the missing piece for me. But state machines in Overmind is based on like the traditional concept of a finite state machine. Where is the thing using state machines? And the reason is because Overmind has split actions and state. They are not the same. So it's very hard to do. Like you literally have to put the function on the same object as state itself. From what I believe. Or you would have like your actions would also need like a current state. Like it would also need to have an explicit state of current. But that would be weird, I think. So that's that's what I really like about just diving back into the basics of the language. It's like, oh, but now we can like solve that. Now that's super simple because we didn't create like, even though, as we talked about before, like the mental model of just having your state tree over here and then your actions over here, like it does create a simplification, but it also, yeah, prevents us from expressing certain things, like having functions tied to specific states. Yeah. Okay. And then we have the next data fetching pattern is revalidate on mutations. Refetch data after a server mutation is performed. This type of approach gives a stronger guarantee that whenever the client requests a server mutation, the data will be synced with what is actually with the server. Yeah. So here we have the same. We have some data, and we call revalidate to-dos, which is, and then, sorry, we call revalidate to-dos, and then we return the actual to-dos with also the ability to revalidate those to-dos. So revalidate to-dos is just updating the to-dos, just fetching all the to-dos again. You know what? Since I'm not doing anything in that catch, let's just do this. I don't care about error handling here. Cool. So in our state now, what we do is that we have our data, we return those to-dos publicly, and we give the possibility to add a to-do. So when we call add to-do now, we're going to await adding that to-do on the server, and then we're going to await revalidating, basically fetching all the to-dos again. That's revalidation. The great thing is now you're certain that whatever happened here on this line, you will have the source of, like, you will have the truth again for those to-dos. Yeah, and this is like a pattern of, like, what's it called? Stale while revalidate, SWR. So that pattern is not like no news, but it hasn't been used in, well, at least not in React until I guess it was Vercel and React query, tan stack query, React query popularized it. I don't like it at all. I think it's like, it doesn't give a great user experience because you have latency. So you can do like, these solutions can, like, and it's all like, and you're fetching so much stuff over the server. Like, it's weird to me. Like, it seems it has such a high cost compared to the guarantees you get from it. At least in my experience. So, but it's definitely valid, right? You get better guarantees, but it has a higher cost in terms of increased feeling of latency in the user experience, and also you're shoving way more data over the wire. And then we have automatic sync, where you subscribe to data and get updates automatically. This type of approach simplifies data fetching and server mutations, as you only interact with the server. There is no manual intermediate step to keep data in sync. So again, we have our data state management. We're just subscribing to some to-dos, and then we just update those to-dos, and we just return it. And then we have our data state, and we just expose the to-dos again. And in add to-do now, we just add the to-do to, oh, this should be persistence. Persistence to-dos add. And that just triggers the subscription. So there's something under the hood that maybe it would optimistically add it, like trigger the subscription. Or it's like just so fast that it feels like it immediately triggers, like Firebase, for example. And then we have data references. So this is really important. I don't think we talk enough about this. Like, we're kind of pushing these like data fetching solutions, and we don't talk about data references. Because it has a performance impact in React. So when you fetch a list of to-dos, the array of those to-dos and each to-do has a reference. In the world of React, those references matter because it is what memo components use to determine if the component needs to reconcile. The pattern of mapping an array in a list component and render a nested item component. Where are we? Item component using memo is the most common optimization in React. If you use a revalidation approach to data fetching, it means that the to-dos array and each to-do in that array will change reference whenever you request any change to the array or any item in the array. In other words, that was a heavy sentence. Wow. Yeah, if you use a revalidation approach to data fetching, the to-dos, I can just shorten it. The to-dos array and each to-do in that array will change reference. On every revalidation. We change reference whenever. On every revalidation. In other words, your to-dos list component and every to-do component will reconcile regardless of any change. Normally, this is no concern as reconciliation is fast, but if you are displaying a lot of to-dos where each to-do has a complex UI, you risk performance issues. Local mutation strategy is what best optimizes references and therefore reconciliation. After that, automatic sync, where you subscribe to specific changes in the data, also best optimizes references and therefore reconciliation. Make sure you reflect on how your data fetching affects your data references and the reconciliation of components. It can be a good idea to default to revalidate on mutations, but optimize with local mutation or a change subscription if available. Yeah, it's very interesting. And then deriving data. In this example, in the examples above, we are exposing data directly to components, but you might want to rather derive data to some state management that exposes the data in a more controlled way. So here we create, and I really like this as well. It's like we just create this, we have to do data, right? We have to do DTO, data transfer object. But then we can just create this to do function, which represents the actual to do, where everything is read-only, and we have controlled functions to manipulate that data. And it doesn't matter how the UI uses this. This is not about what the UI needs to interact with. This is how the state management wants any UI to control any UI, how much it can affect this to-do. So in our state, we have our data, and when we expose the to-dos, we map over them and we create a to-do. Now we're hiding data from the components and gain control of how components interact with it. And then deriving data references. If our data fetching ensures the integrity of data references, we break that integrity when deriving. So here we see the same. We're exposing the to-dos by mapping over them and creating this to-do state management item. So even if our data.todos ensures consistent references, our map will always create a new array, and to-do will always create a new state object. To make sure the to-do state object is only created when the underlying to-do data reference actually changes, we can use a reference cache. So this would be if you use local mutations or you're doing like a specific change subscription to items. You can use this thing, and then it's the same code. Yeah, maybe we don't have to remove this. And now you have create reference cache for the to-do, and then you have a cache to-do instead. So now if you're using local mutation here and you like push to that array, if you have 20 to-dos there, it will just use the same. It will use the same. It won't change. It won't create a new to-do, right? We'll just use what you have. But if you revalidate, all the items in that array is going to change anyways. All the to-dos are going to change reference. So then it doesn't matter. You don't have to do this. So this is just an optimization. So when calling cache to do it, we'll first check if the data reference is in the weak map. If so, it returns the existing state. If so, it returns the existing state. If not, it creates the state as normal and caches it. Using a weak map is perfect because we don't have to clean up the cache. When the data reference is no longer available, the state removes itself. Cool. Optimistic data. With local mutations, you're free to change data in place and rather revert it if the background server mutation fails. But with revalidation, you want to show data that is in flight, often with some UI indication that shows it is loading or show the data as optimistic data. This can be done by exposing a mutation state. So this is something that was actually from work on the Impact React project, which I learned from React Query. Like the thing when you're going to consume a mutation, you can't consume traditional mutations in React because it's just a promise, right? You're just calling the server with some data, and that promise exists in like a click handler or a use effect, and you can't like consume it in the UI. And you have to create a mutation state that's kept up to date based on the promise. So a way you can do that is create a state of like adding to do, for example, or add to do mutation, or whatever you want to call it. And it starts out as undefined. But when you call add to do, you say state adding to do status pending, for example, and you attach the to do that you are going to send to the server. And then we're awaiting all of this stuff. And when it's done, and that means during this time now, the component will reconcile again because it's looking at adding to do. And it can show whatever it wants based on this pending state. And then when it's done, it sets the adding to do mutation to undefined again because we're fine. But if there's an error, we can use the same mutation to set a status error. You can still have the to do there and the error message, and that can be displayed in the UI, right? A component can now use this state to show a temporary to do. So this shows like we have a to do's component. It takes our state and we're kind of listing the to do's here. But if we are mutating in the sense that we're adding a to do, we can check if we have a pending to do, we're going to show that item at the top as pending. And if we have an error, we're going to show that, error. We're going to show that item also at the top, but it's going to have like an error prefix. Like this looks like shit, but the point is that you're able to explicitly show pending mutations in the UI, which basically is optimistic updates, right? Well, I guess it's not strictly optimistic updates. They call it optimistic updates. But I think optimistic updates is actually adding the to-do to the array and show it as if it was already there. But yeah, that's just playing with words. So, but this is the point of doing that. Maybe I'll split this into 2 different ones. So there's like or 3 different ones even. So you have like local mutation, revalidate, and yeah, whatever. So that's that. And then we have promises. And this is also from like Impact React, because this was around when React 19 was in the works, and React 19 has a really amazing feature. It is the ability to consume promises. So you can choose to put promises into your state. This is especially valuable with React, as you can suspend those promises in components. The mental model for promises is often that they act as a temporary primitive that transfers a value from an asynchronous source to a variable, like here. But promises does not disappear when it is resolved. The promise is the value. So you can also say, don't await fetch data, just fetch data. So you have the async data promise, and then you can just await it whenever you want to get the value. You could hold on to the promise and retrieve the value whenever you want. So for example, we can have a promise of a counter and make it reactive. So here we have a state, we have a counter, which is a promise of a counter, and we're just making it reactive when it resolves. And then when we want to use it in our state management, we just have to await it, right? To just get the actual value from the promise. But that's fine, right? If it's not resolved yet, it will wait until it resolves. If it's already resolved, it will immediately run, or like on the next micro task. And then in a component, you can do exactly the same. You can use the use hook and just with the state.counter, and you have your counter, and all of this works. Like, it's reactive and it just works. And if the promise isn't resolved yet, it throws to the suspense boundary, and doing so, it will track the promise, and React will add its internal state to that promise. So when it's resolved and this counter reconciles again, it won't throw to the suspense boundary because it's added details on that promise. And since that promise is in your state management, it's always the same promise, right? So it just optimizes React. So it's very cool. So that's that. And then it's the final one, which I call environment dependencies. And we talked about this as context, but I think context, context is too generic, because the way I think about that context of like bringing in some tools to your state management is that these tools, they are tied to the environment. Like, they're using specific APIs that's only available in the specific environment the app is running in. So that's why I call it environment dependencies. So applications run in an environment. They don't runs, they run in an environment, typically the browser. You might need to use certain APIs from the environment, for example, local storage. It also typically, the application also typically uses certain third-party libraries. For example, you use Firebase for persistence. Your application and its code does not really care about local storage or Firebase. It only cares about persistence. Creating an environment interface for your application is a pattern that can clean up your implementation by removing terminology and abstractions that is unrelated to the application itself, like local storage or Firebase. Additionally, you will often avoid adding explicit types in your application code. The pattern also increases testability, as you do not have to mock the environment during testing. You rather mock your environment interface. We can also apply the constructor pattern here. So here I have like local persistence. It takes a namespace and it just returns a set and get, where it has a create key to like create a key for local storage, where it has like the DOM specific API, local storage set item. It creates the key and it also puts it as JSON, right? Because normally it's just strings. So this just creates like a really nice local persistence API with a set get. It takes a key, it's already namespaced, and it's always JSON. And then your environment is like exposed as local persistence, and we create local persistence. And then your state takes the environment, and this environment could also hold like any like whatever it might be. Like it doesn't matter. It's the environment the app is running in. That's why I like that term. Like your state management has dependencies from its environment, or that needs to come from its environment. Anyways, so here we just use local persistence and we can get the count, blah, blah, blah. And when we increase, we set the count to the current count. And to kind of instantiate it all, we just say environment, call environment with the namespace in this case. We pass that environment into our state, and then we expose the state to the components. And then if your state management is to be shared between, for example, a browser and native application, you can define an environment interface. You can define a generic environment interface. Even though the browser and the native app uses the same state management, they have each their own implementation of their environment dependencies. So here we're creating an interface, like a generic interface for local persistence, which makes it async. And then we have the interface for the environment, which just exports local persistence. And then the browser implementation is, well, exactly the same as we saw. Browser local persistence, it looks the same. And then the native implementation uses async storage. And this is why we're making it async, even though the browser implementation isn't async. The generic interface for local persistence is async. So the change here is that we made both of these async. But here we have like async storage instead. I know this is deprecated, but it doesn't matter for this example. So now you can create, so when you build up your browser UI, you have this like big state management thing that controls your application, and the code is exactly the same. It doesn't care about which environment it's running in. And then you are free to build up the perfect UI in native and the perfect UI in the browser. And I think that's much better. And you can even argue, like kind of tied to this, is like one thing that's often a problem is responsive applications. Like doing a responsive rich client is fucking hell. Doing a responsive website makes a lot of sense, but a responsive application is fucking hell. So what you can rather do here is that when you have your state management extracted like externally like this, you can have a single flip at the top of render, which checks the size of the UI. And then you create two completely different set of component trees. One for your big screen, you have all the space you need. Like that doesn't mean that doesn't have any responsiveness, but the user experience is a certain way because you have a certain real estate to work on. And then the other branch is the actual mobile real estate, which can still be responsive to some degree, but the functionality of it and the actual UI is implemented very differently. But the point is that you have the exact same state management, right? So you can even like, you literally pass the same root state. So when you change the size of the screen and it moves to mobile and like the big real estate version, it's still the same state, but the UI can be completely different. So it gives a lot of benefits related to that. Maybe I should write something about that. Yeah, let's add that. I was actually hoping we would refactor the app, but yeah, let's see. Let's add that as a pattern. 09. Hey, what's going on there? Hello. Weird. Huh. Pattern. What did I call it? Pattern environment. Oh, what happened? Where did it go? Oh, did it cancel? online pattern, multiple views. Or multiple UX. I want to emphasize it's about the pattern, multiple UX. Responsive web application, responsive. The web has gotten far on making experiences responsive. It does not matter how big your screen is. Typically, like I see this now, like we joined together AI, and of course their mobile experience is pretty bad because it's the same as the web experience, and that's the primary experience is using a browser, right? So there's a big effort now to like make all the components actually behave well on mobile, but it will still be a secondary experience because it's the mobile experience isn't a specific design. It's just trying to adjust as good as possible to the primary like browser desktop based user experience. But if we did a pattern like this, we will be able to actually dedicate to a mobile design and a desktop design, and you have the exact same state management. Yeah. Yeah, the web doing responsive design can be a huge challenge in rich applications. Websites, unlike websites, the user experience of an application is many times more complex. Often features can only be responsibly implemented for a desktop experience. Being able to not think of desktop as the primary user experience and mobile the secondary. Doing responsive design can be a huge challenge in rich applications. Unlike websites, the user experience of an application is many times more complex. Often features can only be responsibly implemented for a desktop experience. The result of this challenge is often that the mobile experience is overlooked, or in best case, it tries its best to adjust to the primary desktop experience. When you externally manage the state of your application, you will be able to dedicate when you externally manage the state of your application, you open up an opportunity to have a first class desktop experience and a first class mobile experience. That does not mean they are not responsive. Desktops have different sized screens, and mobiles alike. But the fundamental user experience can can be separated. So as an example, on state, your state management, and then render experience switcher. I don't know. We're gonna find something better. So you can pass the state in there, and then experience switcher is what should we call it? Or we can still call it app, right? You still pass your state at the top of your application, but your app component will completely change out the experience based on the current size of the screen. Function app. How do I do, like, can I ask the AI? Please implement an example of how I check the size of the screen to render either a mobile experience or a desktop experience. Well, thank you. Except that it got doubled. What did it do? Yeah, we don't actually have to show them. Define breakpoint. Handle resize. Yeah, this is fine. But we forgot about the state here. So we get the state. So personally, I think this is a much better way to approach responsiveness in rich applications. It does not make any sense to put a dashboard on a mobile phone. It makes absolutely no sense. What you want to do is, like, you want to think about the user. Like, okay, we have this service for the user. It's this rich dashboard application that can do so many things, control so many things. What do they need to do when they're on their mobile phone? Maybe alarms is more important, like notifications is the most important thing, the health of the system. Maybe they want to easily create an issue. Like, there's certain things you want to do when you're on a mobile phone compared to sitting by your computer and managing this dashboard. And this this approach allows you to just completely separate those two experiences, but still have the same state management, which is just, there is no better way to do this, I think. Okay, so let's do a git status, git add updates. Oh my God. So I'm going to stop streaming. This was a bit different, just going through the docs, but I hope it made sense, reasonable. And I'm going to build something awesome today, so I'm excited about that. And tomorrow we're gonna actually like continue a refactor of the app and kind of make pointers to the actual patterns we're using. So yeah, I like where this is going. Cool. Bye for now.